This video is about projectiles. You should have received this piece of paper in class to take notes on. If not, just go to the Teeter Zone website and print out your own copy. So we first start off with a basic definition. Basically, a projectile is any object that is shot, thrown, kicked, launched, or otherwise projected into the air or space. We're still going to stick with the idea we established in our free fall discussions, and we're going to worry about this as gravity only right now. We're not going to worry about the air resistance. So we do realize that we're throwing things through the air, but we're just going to treat them as if there's gravity only and the air is negligible. All projectiles follow a parabolic path or parabolic trajectory. It's a fancy word for path. And looks kind of like this, a little parabola, just like that. Now, that's pretty complicated looking motion, so we're going to split this up into two different pieces. One of the reasons we talk about vectors first and things like the boat river problem is the independence of perpendicular vectors. So we're going to look at the horizontal motion and the vertical motion. Here is a short video clip of a projectile. So here's a graph of that projectile, and on the axis right here, this is the horizontal position, or the x, and along this axis here is the time. And so we can see here the slope of this line is the change in position over change in time, which is its velocity in the x direction. We can see very clearly here that that slope is constant. It's a nice straight line there. So one of the things that gives us this idea here is that the horizontal velocity or the horizontal motion is constant. So with that, we can use the basic equations for constant motion. We have our speed is equal to displacement over time, and we can also rearrange that to solve for the displacement, which is the speed in the x direction times the time interval. The horizontal displacement is known as the range of a projectile. So we're going to find out how far it goes along the ground. That's the range. So again, the horizontal motion is constant. Next, we want to look at the vertical motion. So with the vertical motion now, we can see that the y position here and the time, now we have what looks like a projectile's curve, a parabola. And the equation for a parabola is in the form of y equals x squared. Right? And the x in this case is the time. So here we're talking about the basic free fall situation here. Right? We're talking about the vertical motion, and we'd already dealt with that in terms of position. We said that to find the vertical position, we took the initial velocity times the time, and we added 1/2 acceleration due to gravity times the time squared. And so that time squared is the x squared in the parabolic equation here. Right? So our position versus time is a quadratic relationship. Alright, now I have another graph here from that same projectile, and this is the vertical velocity versus time. And so when we talk about the graph that's a velocity versus time graph, you have a change in velocity over change in time. That's the acceleration. In this case, the acceleration is the acceleration due to gravity. We have a negative slope here, it's constant. So with our accelerated motion, we use the same equation that we used in free fall. And so now we're talking about our final velocity in the y direction equals our initial velocity in the y direction plus acceleration due to gravity times time. So our vertical motion is accelerated motion, which came from chunk 2 on acceleration. And our horizontal motion is constant motion, which came from chunk 1. So essentially we're just combining together chunks 1 and 2 together here in one motion, the projectile.